Playing with our numbers. We're playing with our numbers today. Look at attendance. If you're here, let me know. Stream should be live now. Got both McDonald boys. We got Camden. We got Leah. We got Mac. Need to get our online people squared away. Then I'm ordering a pizza for lunch. No one's stopping me. Casey's. Big school. Wait. I was gonna order for lunch. Actually, no. Your sister actually. I ordered a pizza. And I tell you that's her own idea. Probably was. She doesn't make sense like that. But that's her idea. Tell the story. How I got a new rule added to the rule book in middle school. But no roll again. Let's go to the office. They stopped me. We all brought money. Like, come to the office. Hey, can I borrow the phone? Sit right there next to the secretary. Turns out she assumed that I was doing strategic. Right? Asked me like pizza shows up. Guy class. I'm like, yeah, I'll be you boys, right? Walk downstairs, pay the man his money, back in, walks out of the office. What are you doing? Can't do that. Like, I did. I used the office phone. No one stopped me. So after that, every handbook has we're not allowed to order. Anyway, I told that story about how I had a pizza right in the wall. But you know, who ordered pepperoni? You know, all this great legend. Better she wouldn't. Good for her. That's what I'm doing today. I guess I'll go pick it up instead of wanna misbehave. If you're here, let me know. Haley, Sebastian, Jordan, Haley. We started the stream and it is live. So I have two nemesis. One, cardboard. Please cardboard. I'm at kid's house. Whiteboard. All broken. Back of the whiteboard. Cardboard was picking it up, right? And had like it was broken. Take it off. That cardboard is carpet. Placed over my blood and everything. Cardboard. The other nemesis. Water metal. Taking apart a teeth. Right apart. Of course, the idiot I am grabs the sheet and pulls up. It's got like flat and then sits down. But edges are sharp when you push it. And I do it every time. And I know it. I tell people all the time, sheet metal and cardboard, sheet metal and cardboard. And I still don't wear gloves when I'm working with it. Make chickens. Good to see ya. Make chicken. They were playing with some numbers. The story goes like this. Yesterday. No. Hey, Danny Mao, you might know him. About this high. Danny came in here. My student last year. And what's up, Eads? You know, smart kid. And he had a quiz last week. I was asking him, you know, how his school year was going. He had a quiz last Friday. It was on inequalities and absolute value. Question like that on the board. And it's like, okay, so tell me about it, Danny. He's like, oh yeah, I got an A. It was easy. Like, okay, And he gets up there and he solves. It's like, okay, well, one version you got to write where it's positive, another version negative, and then you solve and you get your answer. It's like, great, fantastic. What are we solving for? What does that even mean? Like, what is absolute value? I don't know. What does this tell you? What does the answer being 11 or -1 mean? I don't know. No clue. Kid aced the quiz. Isn't it amazing? Hi, Haley. Isn't it amazing that we spend so much time and so much energy and so much misery in school, and we can even get A's, right? And we still have no idea what we're talking about? But, like, why? Why spend that much time and energy to not really learn anything? Because, like, eventually he's going to forget that, oh, yeah, the way to do this is you write a positive version and a negative version, and then you solve it. Like, but why? Well, because that's what I was told to do. What if they're lying? I don't know. How would you know? How would you know if your teacher was telling you the truth? Wouldn't. Right? I used to make a joke all the time when I used to teach calculus, because I didn't have a math degree then. I still don't technically, right? We talk about that. And I'd ask them every day what the derivative was. What's the derivative? And they would struggle to come up with the answer. It's like, God, what is it? What is it, guys? You need to know what this is. It's what we're doing all the time. We're taking derivatives of everything. Don't know what it is. Eventually they got it. But the joke was that when I was done teaching them for the semester, because I was doing maternity leave for the real teacher, she was actually my old calculus teacher in high school. That was awkward. That she'd come back and like everything I taught them would have been just like made up, because I don't know math. I don't have a math degree. Making crap up. Like, oh yeah, here's how you solve this problem. You know, derivative of 2x is just 2, and the derivative of 2x squared is 4, because you take this and multiply it to that, and oh yeah, and this one keeps the x. And they're like, oh, okay. But imagine, like, I could totally been making that up. And then the real teacher comes back and is like, what the hell? What do you mean? It's an exponent. Luckily, I didn't lie to him, but I could have. First rule in here is trust no one. Trust no one. So it's funny, right? Danny didn't know what the hell he was doing. Still got an A. What an idiot, right? You know, like, make fun of Danny. Before we do this, oh, okay, good, okay. I was worried we were going back to that. How do you know that equals 14? Can you explain that to me? Pretend I don't know. Pretend I'm a kindergartner. It costs 0 Jack's Pizzas? Oh, Zed, I miss you. Great, good reference. Valorant. Right, I'll check it out. I've heard of it. Let me open up Steam right now while I'm teaching this class. How do you know 7 plus 7 is 14? By the way, tell Danny I'm talking about him. You guys know Zed Coke? Good guy. He does the BMXing. How he gets all the ladies. How do you know 7 plus 7 is 14? Could you explain to a kindergartner why that is? You guys are high schoolers. You can't explain this. This is ridiculous. Yeah. Ooh. So how would you do that? Okay, so we're using fingers, like, yeah? Okay. You had 7. And you had 7 more. Uh-oh. Ran out. Guess we could use toes, but then you gotta take your shoes off. That's a health hazard. 7 more, right? Well, I ran out after 3. Right? Add on those last 3. And you know that this is 3 because there's this thing called subitizing. It's where if you add 4 more, you're onto something. So subitizing is this. Anything 5 or less, pretty much, if there's 5 dots here, you don't need to count each individual one, do you? You can tell it's 5 just by looking at it. But as soon as we get to more than that, you can't just tell without looking, right? It's not much more. 1, 2, 3, 4, 5, 6, 7, 8, 9, maybe if that second one counts as another dot. High schoolers can do, and adults can do about like up to 6 in subitize pretty well. But after that, we have to count. Younger kids, it's like 4. If you show them 5 objects, they have to count it to make sure, right? 7, oh man, that's out of everybody's league. That's too much. Yeah, it's hard to understand even what 7 means, right? Like, we talk about like a billion, like what does that even look like, right? $1 billion. None of us have any clue. But it turns out numbers like 7, we also kind of don't really have a good grasp on either. I can't do 7 dots and you just look at it and know it's 7. You have to kind of count them. So it's helpful to rearrange things in ways that we can understand it better. And 7 plus 3, and then 4 more, well, that gets us 10, right? And then I've got 4 more on here. It's not on Steam? Yeah, I don't have it on Steam. I was looking, I saw that. I appreciate that. Play Valorant, okay. And 10 plus 4 is obviously 14, right? That's easy to show to a kid. When I say something like 10-1 or 10-2, you know what that means? Yeah, you're not sure, right? What if I say 21 or 22? You do, right? Isn't that weird? How 21 makes sense, but 10-1 doesn't? 11, right? Well, it's because we're amalgamation of a bunch of different languages. We went to base 10 because it's easy to count with 10. Base 10 means you start over at 10, right? Base 12 is the clock. After we get to 12, we start over, right? Base 10, we start over at 10. We have the first 9 numbers that have all their unique names, right? And then at 10, we start over. You ever thought about the word 13? 13 is like 23. It's just the 3 comes first. You say 3, 10, 13. We say teen instead of 10 because teen just sounds better, I guess. They just added on another E. 10. 3, 10, 13. But 12 and 11 are weird. Right? 12 sort of has 2 in there. 11 is bizarre. It's because of like German and French and coming in here. And we used to be a base 12 system. After 12, we'd repeat. That's why we have 12 on a clock and not 10. But then we switched to 10 because 10 fingers. Nice. Makes it easier to learn. So 10s are really nice. We talked about that yesterday. If you're in class, right? Talked about that yesterday. This can help us solve problems that actually are more difficult. Worthy of a high school smooth brain, right? How would you do that and prove what it equals? Yeah. 5 and a 2 and get 7, and then what? So what you really meant was 50 and 20, right? There we go. 50 and 20, and then 7 and 7, and that's 14, 84. Now 50 and 20 doesn't make 57, right? I took the 20 from over here and I moved stuff around. It's okay to move stuff around because of the associative property. We talked about that yesterday. And on the test, there will be no test in here. But on a test, right, they want you to know the associative property. That way when you see it, you can say, oh yeah, it's the associative property. No one ever tells you why it's interesting or why mathematicians cared about it in the first place. And it's because it makes math easier, right? Adding this straight up is hard, but doing 50 and 20, oh, that's easy. 7 and 7, 14, 84, right? Play with your math. Now imagine if we had done this. This problem right here is a tough problem, but it's probably not too hard for a 3rd grader, probably not too hard for a 5th grader. Let's say 7th grade, okay? By 7th grade, everybody should be able to handle this more or less, right? Now imagine if since 7th grade we've been playing with numbers. You'd be pretty confident that that's 84. Because there's lots of ways to show it. Give me another way you can show that this is 84. We did this way, right? Go. Go. 70 and 20? Yeah. So he rethought of 27 as 3 and 24. And that's helpful because this is easily 60. And now you have 60 plus 24. What's that? Easily, right? What's another way to do it? I'll go back, Mac. He said, I'm going to think of 27 as 3 and 24 instead. Oh, you're trying to think of one. Okay. All I can see for your emotions is right here. That's all I get. So I'm having to take a guess. I can barely understand what you're thinking when I have your full face to look at. What's another way to think of 57 plus 27? Make it easy to do in your head. Imagine you're at the mall, and you don't know what a mall is because you're a millennial. But there used to be these places you go to buy things. Okay. And you go into the parking garage. You know what a parking garage is, right? Okay, gotcha. Yeah, okay. Right? You're out there and it's dark at night and you're fumbling for your keys and you get them in and you're about to stick in the car and then all of a sudden you feel a sharp point in your back. The guy says 57 plus 27. Punk, what is it? You have to answer. You have to be sure. How can you be sure? Right, well, one way would be to do this, right? I'd be pretty confident saying 84. Yeah, go ahead, Camden.
You do 20.
Camden. Is that who's talking? I can't tell who's talking. Clearly 84, right? Well done, yeah. So you're just saying, let's do this, and let's do these two, which gets us 77. And you feel confident in 77 plus 7, huh? Okay. If you know 7 plus 7 is 14, you might feel confident, right? It's not going to be 14, it's going to be 84, right? But you could also do 77 plus 3 plus 4, right? To be sure. Yeah. Any other ways? Yeah, go ahead. Yeah. I think it's one we did earlier. Was it you or your brother that did that? Probably your brother. That's okay. We should not be shocked that we're repeating answers because the answer's always 84, guys, right? Like, we're going to come up with ways that are similar, right? Some people might say do 7 and 7 and then 50 and 20. Well, is that different than what we did? Maybe. I don't know. They're all really the same. Did you have your hand up, Leah? You did? What do you want to say? Okay, 2 7s together. So that's what you were going to say, the thing that I think I stole from you. Sorry. Right? And then we do this. But you did this first. Yep. Yeah, it's a matter of what you think or what you want to do. So Leah might like that better because she's used to adding this way, which is a really good method because it guarantees the right answer. You just have to remember to carry the 1 and what you had down here before in your head, right? Why does the teacher teach it that way if most of the time you're not going to have a piece of paper near you? Because, right, they always love saying, well, you're not going to always have a calculator. But then they teach this. I'm not always going to have a piece of paper. Bigger numbers, I'm not going to be able to remember what the first 10 numbers were, and I got to carry a 5 now, right? Yeah. Why do they teach it that way? What do you think? I mean, it works. Why? Why do they teach it that way? Ooh, that's a really good answer. That's a very common answer. That's definitely true. You got something else to say, Camden? Yeah, you don't have to think about what 57 means or what 27 means, do you? You just do it. So it's quick. Why do they want you to be quick at math? Ooh, we'd hate to be stuck on one problem for a long time, wouldn't we? We'd hate to have to think for a long time, wouldn't we? Right? Why do they want you to spend little time on a problem? Because I want the opposite. Why do they want you to spend little time on a problem? Get over and get the next one, because they want what? They want the answer. That's the most important part, right? That makes sense. Again, I'm not saying that's a bad thing. Obviously, my opinion is I think it's a bad thing. But like, if that's what you wanted to do, this would be a great method to teach that. Now, again, you're not going to always have a piece of paper with you. So why do they teach that way? When do they want you to have the right answer? Not always. I mean, ideally, we want you to always be able to do this, right? But if we did, we wouldn't teach this method, right? Because you're not going to have a piece of paper with you most of the time. So when's the time they really want you to have the right answer? Yeah. Sure, but that can be any time, right? When do they want you to figure it out? Especially in class. You have a piece of paper. When do you have a piece of paper in class? They give you one. When they usually give you paper, what are they doing? Homework. Tests. If their goal is to make sure you get it right on the test above any other time, this makes a lot of sense to teach you it that way. And it's not a bad method. Don't go home and tell mom and dad, oh yeah, I learned that that's the fine method. It works every time as long as you follow the steps and don't make mistakes. And again, as long as you follow the steps. You're not thinking about what this means. You might get a wrong answer and not realize that it doesn't make any sense, right? If you got this, that looks just as right as any other answer you might get, right? But unless you look, oh, I missed a step, right? Now, if you know 57 and 27, well, that's more than 50, that's more than 20. How could it be 74, right? No way. Couldn't be. Maybe, but couldn't be, right? You're thinking about what 57 and 27 mean, though, and that takes time. If they want to make sure that you get it right and do it quickly, They drill and kill. That's what we call it, right? We keep doing it over and over again. We practice using this method. Carry, 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 right? Here's how you do it. Borrow. Sure, exactly. So, but that takes thinking. If they want to make sure you get it right and quickly, the best way is to drill and kill. Repeat, right? No thinking. Do it quickly. This is fine. If you just need the answer, this is a good way to do it. And you have a piece of paper. But this, probably faster. I can do that in my head faster than you can probably write that down. I had a friend in high school that was really good at calculation. Really good. He was so smart. And I'd always wonder how he'd be able to do questions like this instead. 57 plus 27, 84. Wow. How do you carry the thing and do, not only just remember it, but do it that quickly? Yeah. Well, he just had different ways of thinking about it. Imagine if we'd spent time thinking about numbers since, I don't know, 7th grade, maybe 5th. You could do this in 5th. Come on, right? It'd be a harder problem, but you could do it. Yeah, maybe, right? What if we spent since 5th grade playing with our numbers? This would be boring. We wouldn't be talking about this at the high school level, would we? You wouldn't be learning something today. You'd be like, yeah, I learned that already. I know how to find 57 plus 27 a million ways. We don't. Instead, we do this one way, and we repeat over and over and over again. Why do we have to repeat it over and over again? Because if you don't repeat it over and over and over again, you won't memorize it. If you don't memorize it, then you didn't learn. We have to spend all this time and all this year and all this struggle repeating over and over again in order for you to have learned how to add. Now, one would think when you learn things, over time it gets easier, right? Well, I learned that a while ago, so now it's an easy problem for me, right? Is 57 plus 27 any harder than it was, or any easier than it was when you were doing it in 5th grade? No, it's just as hard, isn't it? You got to do the same thing. Seems silly to me. Right, exactly, right, yeah. Can't memorize them all, can you? But you can see the connections if you spend time thinking about it. What's another way we can solve this problem? Any other ways? We did the 50 and 20 and then the 7 and the 7 and add them together, right? We can move things around, right? Associative property. We can move things around. It totally doesn't change the problem. Yep. Yeah. And we can do, make this a 60, right? Make this a 30. Another way that I saw somebody do this was this. Look. I'm going to estimate. Right? That's what they did. Isn't 57 just the same thing as 60 minus 3? So it's just going to be 90 minus 6, which is 84. I want to show you something else that's not really... It is, right? And again, it's kind of weird to think that way. But sometimes it can be easier. And I'm not going to tell you what the best method is, because it depends on the situation, right? Yeah, it's a really smart way of doing things. I want to show you something. This is what Parker Porin did. He divided. And you're like, wait, what? In what world is division easier than addition? I don't know, okay? Well, let's humor him for a little bit, okay? First of all, how does he know that 57... Oh, what's up, Zach? Hey, buddy. How does he know that 57 divides... 3 divides 57 evenly? How does he know that 3 goes into 27? How do you know 3 goes into 27? Tell me. Yeah. It's 9 because you memorized it, right? You memorized your 9s. What if you didn't memorize your 9s? How can you be convinced that 3 goes into 27? Prove it to me. Well, 3 and 3 and 3 and 3, if you count them all up, right? No. I had a PE teacher that sounded like that. His name was Mr. Pax. Ah, the Ty Brothers! Once again, 35-5. Good time. Oh, here comes the stinker! And he rubbed the ball in his armpit and then roll it. Love Mr. Pax. How do you know that it's 9? How can you be sure? Explain it. Yeah. Say it again. That's true, but what does that mean about this? Not sure. Spitballing? That's okay. Feel free to spitball. How many times does 3 go into 30? Sorry, I got a mask on. I'm speaking quickly. 3 go into 30. How many times? Are you doing the finger trick? That's cute. You guys learn the finger trick. You put down the whatever, and it shows you what it is. Right? I don't know it. I have a joke about tricks, but I don't want to do it. It's kind of inappropriate. But it's funny, and it makes a good point. But yeah, that's one way to do it. Show them the trick, right, for 9s. I want something a little more universal. This happens to be 9, you know what I mean? What if I asked you 33 divided by 3? How would you know? But good thinking. You're the second person to do that today. Well done. How many times does 3 go into 30? So how do we know that 3 does go into 27? Yeah. Okay. You subtract 3. It's 3 less, right? Yeah. Multiples of 3. If 30 is 3 groups of 3, how much must 27 be? 9. 1 less group, right? 1 less group of 3. 57. How do I know it goes? 3 goes into it. Go, Camden. 1 less group of 6, or 1 less group of 3 than 60. Yeah. How many times does 3 go into 60? 20. So how much must this be? And now you look like a god, right? 57 divided by 3, 19. What the? Right? That's me sitting next to my friend Jake in high school. What do you mean 19? How? What? What? And the teacher's like, oh, I'm not sure if that's right. And they pull out the calculator. It's like, first of all, that teacher does not really understand math, right? Come on. Now that you know, it's like, of course. This isn't a trick. This is logic. Right? This is a trick, you know. That's fine. Fine. Tricks are fine. You don't know why it works. You just know it does, right? And if that's all you need is the answer, that's good. And school focuses on the answers. Why? Because all that matters on the test is the answer, right? But man, imagine if we'd spent since 5th grade doing stuff like that. Division. Oh my God! No, it'd be like boring. Yeah, you know, 80 divided by 5, or let's do that. 75 divided by 5. Maybe you don't know the answer off the top of your head, but I bet you know 100 divided by 5. 20. That's 5 groups of 5, right? Right? So it's gonna be 15. Or what's another way to do this? Instead of rounding up to 100, what could we round down to? 50. That's 10 groups. 25 left over. That's 5 groups. 15 groups. Cam, did you have something to say? I apologize. Did I take the words out of your mouth? Okay. That's why I need to ask the questions and not also give the answers. I'm trying to get better about that. I get excited. Exactly. You can do it whenever you want. Doesn't matter on 9s. Doesn't matter what we're talking about. You can do it. So the Jewish people have an expression called turning the gemstone. And this idea is that if you look at a gemstone, and this is not a gemstone, but it's the best thing I have, and put it in the light, it'll refract the light and make like a rainbow. It'll make different colors, right? And if you turn it just slightly, yeah, if you turn it just slightly, not this guy, but an actual gemstone, if you turn it just slightly, it'll change the hue of the colors. It'll give you a different set of colors every time you turn it just slightly. And so the Jewish people say to turn the gemstone, to take a problem and look at it from all the different angles so you can see all the different beauty that it can produce. Every single color. And every time you turn it, it's a new color. A color that's never existed. We are turning the gemstone on 57 plus 27. Look for new ways. All about perspective, guys. That's algebra. It's all about perspective. We do not change the problem. We change the way we look at it. Yeah. Oh, of course. Anything we do in class, if we do it in class, it must be worth talking about, right? Otherwise, why am I talking about it? I encourage you to write stuff about this. Absolutely. Absolutely. If you think it's worth doing. If you don't, then don't. Right? Yeah, it's worth doing. Yeah. So Parker says I can divide by 3, but here's the thing. What do I get? I get 28, don't I? And the reason I know it's 28 is because that's 19 plus 1 plus 8. I'm going to say that again. 19 plus 1 plus 8, right? That's 20 plus 8, 28. I was supposed to get 84. So what happened? Well, we changed the problem, right? The original problem was this. And then we divided it all by 3. Yo, Camden. Uh-huh. And why does this work? We multiply by 3 once, but we divide it by 3 twice? Couldn't we multiply by 3 twice? Why? Because, yeah. Yeah. Ooh, check this out. Another way to think of this is dividing each by 3. Divide them both by 3, right? When I use the word quantity, right? We talked about this the other day. Quantity, it means amount, right? Cuando. The amount. 5 is a quantity, 6 is a quantity, 57 is a quantity. 57 plus 27 is a quantity. So numbers can be quantities, but so can multiple numbers, right? What is the quantity of 57 and 27? Well, it's 84, right? It's the quantity of 84 just written a different way. You know how in English class you use parentheses to be like, it's 84, right? Something like that, like as an aside. The quantity of 57 plus 87, or 27, it's 84, right? That's what we're doing here. Treat this as one idea. That's what parentheses mean. Treat it as an idea. Don't be in middle school and go, parentheses 57 plus 27, parentheses, oh my God, no. No one knows what you're talking about, and you're hurting yourself, right? And you're embarrassed, right? Remember me reading the math problem out loud in math class and how embarrassing that was? Yikes. And then the teacher's like, very good. Now that you've read parentheses 57 plus 27 parentheses, now we all really know what we're talking about. We're ready to do math, right? Now we're ready to do the problem. No, you're probably more confused than we were before. The better way, I think, is to say quantity of 57 plus 27. So, you know, treat it as its own idea, right? We don't say quantity of 5. We can just say 5. I'm sorry? Yeah, you can say in parentheses. That's fine. Yeah, fine. Yeah, I don't want to say there's a best way of doing things. It's whatever you're comfortable with. I think we can all agree the parentheses 57 plus, right, is a mouthful. And it's hard for other people to understand. So make sure it's understandable for you and your audience, right? But we times this by 3 only once because we really just did divide it by 3 once, didn't we? We took this whole thing and divided by 3. You can do it individually, or you can do it all together. And this is all together 28, right? So if we wanted to, we could do this and times them both by 3, right? And that would make sense because we divided each by 3. Now we're going to times each by 3. That would work, right? Or you can put them together and get this, right? Once each. Does that make sense? Sort of? Okay. There's this idea called a term. 57 is its own term. 27 is its own term. 28 times 3 is a term. It's all together. You can't separate it. Why? Because this is 3 groups of 28. If I just said 3 groups, does that mean anything to you? No. They go together. Their meaning changes if you separate them, right? So you're not allowed to be like, oh, I've got this problem. Right? I'm going to use parentheses for organization. You don't need parentheses there technically because of PEMDAS. Use it for organization, right? You see those problems on, social media. It's like, Chinese 5th grader can solve this, can you? And it's got all these different signs. And like, no, who cares, right? I have free will. If you wanted me to solve it, you'd put parentheses so it's easier for me to read. So can we just add the 3 and the 4 here? No. Well, because you're supposed to do parentheses first. No. You don't have to do anything. The reason we can't add the 3 and the 4 is because this is saying 3 groups of 4 and 3 groups of 5. So we're saying 3 groups of 4, 3 groups of 5. So this is 4. This is groups of 3, right? These are the groups. These are the numbers. So we have group and a number. Can we just add those together? No, we can't do that, right? It doesn't mean anything. They only make sense in context when they're looped together. So you have to leave them together because they're treated as an idea. That's what those parentheses mean. Treat this as a quantity. It's really 12. Treat this as really 50. But if you want to, think of it like that. I'm going to read this aloud to you. Don't tell me what the answer is. 3 groups of 4, 3 groups of 5. How many groups do we have? I'm sorry. Let me read this differently. Let me write it out differently. English goes a certain way. It makes it easier. 4 groups of 3 plus 5 groups of 3. What's that going to equal? 4 groups of 3 and 5 groups of 3. What's that? Right? 9 groups of 3. So you can do it like that, or you can do it separately and do 12 plus 15 and get 27. Right? 4 groups of 3, 5 groups of 3 is 9 groups of 3. That's what it means. Get out of here. Imagine if you knew that. Make life a lot easier, wouldn't it? We'll talk about this more tomorrow. We might even get subtraction in there. Go home and write about this if you want to write about it, and make sure if you do want to write about it, you do it soon, that we don't forget, right? Or watch the video online. I make yours separate from the rest of the geometry, so it's a shorter video, but you can always fast forward. Don't wait to write a